Assalamualaikum warahmatullahi wabarakatuh. Kita sambung lagi berkenaan dengan integrations, topic of integrations. So kita sambung still topic 7.5 area of region, but in this case kita nak tengok area of region which bounded by two curves. Baik, saya ada example 1, example 2 illustrated in the diagram. So kita refer the first diagram. So kita ada on the first diagram we have a functions of fx and gx. Okay, kita ada fx, kita ada function of fx which is saya lukis di dalam color biru. Then we have a functions of gx which saya draw dia dalam color ungu. Okay, then in order to find the shaded region bounded between these two curves, okay, the formula is very easy. Okay, di mana kita akan buat integrations. Okay, integrations is actually from the limits of a to b, whereby a and b is actually the value of intersection. Okay, the value of intersection between these two curves. Okay, alright, and then untuk kita integrate dia, so formula yang kita akan pakai adalah we are going to do the integrations of fx minus gx, whereby fx must be greater than gx. Okay, so bermaksud dekat sini, bila mana fx is greater than gx, dan kita akan lakukan integrations, okay, the limits between a to b, and then fx minus with gx. Ataupun saya lebih suka tulis dekat sini, the second hint that saya boleh share dengan pelajar adalah atas tolak bawah, above minus below, above minus below. So we can see that the above curve of this shaded region is actually fx, and the below curve of the shaded region is gx. So then dekat sini kita akan ambil fx minus with gx. Okay, it's very simple. Okay, very simple. And kalau kita tengok dekat shaded region on the second graph dekat sini, okay, we have fy gy. Now we have a function in terms of y. Okay, because we are going to do integrations with respect to y. Okay, so with respect to y, dy. Okay, then the same thing, we have fy and gy. Okay, this is the shaded region, the color kuning. Okay, then we have limits from c to d. Actually, the limits of cd here is the intersections of these two curves. Okay, we are going to do the integrations with the limits from c to d. Okay, then untuk case ni sama juga, kita akan tolak fy minus gy, di mana we notice that fy is greater than gy. So how to notice fy is greater than gy? The same thing, fy is lying on the right side and gy is lying on the right on the left side. So it means that fy is greater than gy in this case. Okay, so since fy is greater than gy, therefore kita akan lakukan integrations from the limits of c to d, which is fy minus with gy with respect to y. Okay, so let's start with first example. Find the area bounded by the curve y is equals to x cubed and y is equals to zx. Okay, now in this questions we are looking for area which is bounded between these two curves. Okay, so y is equals to x cubed and y is equals to zx. And first we are going to sketch the graph accordingly. So kita akan sketch graph. So kita akan sketch graph. Alright. So now we're going to start with so this is y-axis. X-axis. Kita akan mulakan dengan y is equals to x cubed. So y is equals to x cubed, we're supposed to have in this form. Okay, which is S shape. So this is y is equals to x cubed, and we are going to have set x. So this is a set function. If you still remember, for set function, set x means that x must be greater or equal to 0. Therefore we are going to start from the origin, then the curve will go to the right side. So y is equals to set x. Okay, and the region that we're looking for is in this case adalah this part. Okay, So this is actually the region that we're looking for. Okay, all right. So now in order to find the area of this region, of course, as we discussed earlier, kita nak kena dapatkan dia punya intersection point in this case. Okay, on X. Okay, intersection point on X. Sebab daripada sini kita boleh dapatkan region on area lah. So kita boleh integrate this function with respect to X accordingly. We start with intersection point. So for intersection point, okay, we're going to do simultaneous since they are sharing the same point here for y equals to x cubed and y equals to x. Then I'm going to say that x cubed is equals to x. Okay, then squaring both sides in order to have x here. Then saya akan dapat x to the power of 6 equals to x. Okay, x to the power of 6 minus x equals to 0. Then saya factorize. Saya akan dapat x to the power 5 minus 1. Therefore, x will be equals to 0 and 1. Okay, so here we're supposed to have 0 and 1 for our intersection point. Okay, then we have to rectify which one is greater than for this function, as we discussed earlier also. So in this case, we can see that this curve, okay, which is yang berada di atas ni adalah merupakan function of set x. Okay, yang berada di bawah dekat sini adalah function x cube. So means that we can say that set x is greater than x cube. Okay, so set x is greater than x cube. Therefore, in order to find the shaded region, we're going to do the integrations from the limit 0 to 1. Since set x is greater than x cube, we can say that set x minus with x cube dx. Okay, so this is actually area of shaded region. Okay, which is set 0 to, we are going to do integration from 0 to 1, set x minus x cubed dx. Okay, now let's do the integration. So x to the power of half is actually, we're going to have 2 over 3x to the power of 3 over 2 minus with x to the power of 4 over 4, which is the limit from 0 to 1. Okay, then we're going to substitute the limit accordingly. We're supposed to have 2 over 3 minus with 1 over 4. Okay, minus with 0. So therefore, final answer, we are going to have we equalize the denominator. We have 4 times 2 becomes 6. 4 times 2 become 8 minus with 3. Okay, over 4 times 3 is 12, which is equals to 5 over 12 units squared. Okay, so this will be a final answer. Okay, so let's move to example 2. So we are still going to find the region bounded between these two curves. Okay, so the area of the region bounded by the curve of x equals to y squared, and we have x is equals to 3y squared minus 6. Okay, and we're going to find the area between these two regions. Okay, so this question asks us to set up two integrals with respect to x and y to find the region bounded these two curves, hence evaluate the area of the region. So firstly, we're going to sketch the graph as usual. Kita akan sketch graph dia. So in this case, we have x in terms of y. So for this x equals to y squared. Okay, so we're going to have this as y axis and this is x axis. So for graph of x equals to y squared, okay, kita akan dapat graph dia seperti ini. So this is actually graph of x equals to y squared. Okay, and we're going to find the graph of x equals to 3y squared minus 6. Okay, so since minus 6, okay, means that this is actually at the x-intercept at minus 6, and we're supposed to have a graph of something like this. Okay, it is a U shape as well when you look on the other way around. Kalau kita tengok dekat sini, kita akan dapat bentuk U shape sebenarnya. It is a quadratic in terms of y. Okay, so you boleh sama juga dengan for x equals to y squared. Kita dari sudut pandang di sebelah sini, so kita akan lakukan proses of U shape di sebelah sini. So this is actually the graph that we have from this curve, and we are going to find the area which is bounded between these two curves, which means that I can say that this is actually the region that we are looking for. Okay, so I highlight dulu. Alright. Okay, so in order to find this curve, in this case kita akan lakukan proses of integration in terms of y. Because why? It's easier for us to find the regions of this curve bounded between these two curves, whereby kalau kita dapatkan nilai y dekat sini, so it will be covered for all of the region bounded between these two curves. Kalau kita ambil dekat x, means that it's too hard actually. You can also do by x, but dalam contoh ni lebih senang kalau kita lakukan integration in terms of y. Okay, so let's start with finding the intersection point of y actually. So the intersection point, dia akan kita akan lakukan simultaneous juga dekat sini. So this is actually, x is equals to 3y squared minus 6. Okay, then intersection point will become y. Okay, y squared is equals to 3y squared minus 6. Okay, then we're supposed to have 3y squared minus 2y squared become 2y to the power of 2 minus 6 equals to 0. Then we are going to have y squared is equals to 3. Therefore you're going to have set plus minus set 3 as a y-intercept. So this is actually set 3, okay, on the positive, and on the negative of y we're supposed to have negative set 3. Okay, so dekat sini ini adalah merupakan point of intersection tadi. Okay, so point of intersection. Then of course we are going to do the integrations. Okay, so kita akan lakukan integrations since we are looking for area of bounded region. Okay, whereby we're going to do the integrations from minus set 3 to set 3. Okay, of course now we have to rectify which one is greater than. Untuk this case kita akan tengok graf yang mana yang berada di sebelah kanan. So kalau kita tengok dekat sini graf yang berada di sebelah kanan, so on the right side is actually the graph of y squared, and this curve is actually the graph of 3y squared minus 6. So we can say that y squared is greater than 3y squared minus 6. Okay, so since we notice that this y squared is greater than 3y squared minus 6, therefore kita akan lakukan, okay, y squared minus with 3y squared minus 6. Okay, so I put a bracket first, okay, so that kita takkan silap so dy, make sure you put bracket so that you takkan buat silap dalam simplify nanti, sebab this one we should expand actually. So now we proceed with expansion or simplify. So saya akan dapat minus set 3 to set 3 with limits of minus set 3 to set 3, and then y squared minus with 3y squared, I'm supposed to have negative 2y squared, and then plus 6 dy. Okay, now we proceed with integration. So minus 2y squared, we're supposed to have minus 2 times with y to the power of 3 over 3, okay, plus with 6y, and we have a limit from minus set 3 to set 3. Okay, right. Okay, then we substitute our limits accordingly. So we are supposed to have minus 2 times with, okay, set 3 to the power of 3. So I can say that this is actually 3 to the power of 3 over 2 over 3, plus with 6 set 3, okay, minus with, now we have negative, so become positive of 3 to the power of 3 over 2 over 3, then here become minus 6 set 3. Okay, alright, so now by calculating this value, we're supposed to have a value which is, you akan dapat nilai dia adalah 13.856 unit squared. So this will be a final answer. Okay, so now let's discuss example 3. Given the curves fx equals to e to the power of x, and we have gx equals to x squared minus 1, and the lines x equals to 1 and x equals to minus 1. Sketch the region bounded by the curves and the lines, hence show that the area of the region is 3e squared plus 4e minus 3 over 3e unit squared. Okay, so first of all, of course, we're going to sketch the graph of, okay, because the question asks us to sketch the region bounded, okay, between all these curves, these two curves, and also these lines, okay, which is we have a curve of e to the power of x and x squared minus 1, and we have lines which is x equals to 1, x equals to minus 1. Okay, so let's start sketch the graph accordingly. So kita akan sketch graph. Okay, so this is y-axis. So y-axis, and this is this is x-axis, right? Then we're going to sketch the graph of e to the power of x. So remember, e to the power of x is exponent with base e, so we're supposed to have these types of shape for exponent, which is intercept 1 at on the y-axis. Okay, so yang ini adalah merupakan e kuasa x. Then we're going to sketch the graph of quadratic. We have x squared minus 1, and so let's say here is minus 1 as a minimum point, so we're supposed to have this curve. Okay, alright, so this is, let's say this is 1 and this is minus 1. Okay, this is actually the graph of x squared minus 1, and we also have a vertical line which is x equals to 1 and x equals to minus 1. So so let me choose this. Okay, so kita ada vertical line for this one. Sorry. Okay, kita akan ada vertical line. Okay, so this is actually x is equals to 1, and another one, sorry again, sorry. Alright, so okay, so this is actually x is equals to 1, and we have another one which is, okay, so this is actually x equals to minus 1. Okay, so the region that we're looking for is actually this part. Okay, so kita nak region yang ini, okay, which is bounded between curves and also lines. Okay, so this is actually the region that we're looking for, R. And we notice here that we don't have to find the intersection point in this case, because why? We are going to use, okay, we are going to use this x equals to 1 and x equals to minus 1, okay, as our limits for integrations in order to find the regions of this area bounded with the curves and lines. So we're going to start with so we notice that, okay, so sebelum tu kita kena notice yang atas ni adalah merupakan the functions of e to the power of x, and yang berada di bawah dekat sini adalah merupakan functions of x squared minus 1. So therefore we can say that e to the power of x is greater than x squared minus 1 from the graph. Okay, so ataupun kita boleh kata above minus below. Okay, above minus below. Okay, then we're going to start with finding the area which is bounded okay, between curves and line, okay, which is equals to integrate from -1 to 1. So here we can say that e to the power of x minus with in bracket of x squared minus 1 dx. Okay, then for this one we're going to simplify. Okay, we're going to expand this. Kita akan dapat e kuasa x tolak x kuasa 2 tambah 1 dx. Okay, integrate from -1 to 1 bits. Then we start with integrations. E kuasa x, we're going to have e to the power of x minus with x to the power of 3 over 3 plus with x. So now we have a limit from -1 to 1. Okay, then we're going to substitute. Okay, so we're going to simplify and substitute the value of limits accordingly. Then we're going to have e to the power of 1, which is e, minus with 1 over 3 plus with 1, and we also have minus, okay, e to the power of -1 plus 1 over 3 minus 1. Okay, so now we're going to simplify this. Kita samakan pembawah dia. So kita akan dapat dekat sini, which is so let's say that dekat sini saya akan dapat e plus 1. Okay, saya letakkan e plus 1. Okay, e plus 1. Okay, minus with 1 over 3. So kita nak samakan pembawah dia. So which means we are going to multiply with 3. Okay, hold on. So means that here saya akan darab dengan 3. Okay, so multiply with 3. Okay, minus with 1 over 3. Okay, so something like this, and then minus with this one. So we have e to the power of -1 is actually 1 over e. Okay, so 1 over e. Let's say that saya selesaikan yang ini dulu. Okay, so 1 over e, so here, so 1 over e plus with 1 over 3, we're going to have 3 plus e over 3e. Okay, and then minus with 1, which is we are going to have 3 plus e minus with 3e to the power of e. Okay, therefore so now we're supposed to have e minus with 3e because we got minus 2e. So then 3 minus with 2e over e. So we're supposed to have this. Okay, so kita akan dapat dekat sini minus with, okay, 3 minus 2e over e. Okay, sorry, sepatutnya dekat sini 3e so 3e. Okay, 3e. Okay, then we have 3 plus e minus with 3e, then we got minus 2e. Okay, so then here we're supposed to have minus over 3e as well. Okay, 3e. Okay, then now we start with solve for the operations of minus. Okay, kita akan dapat, sini saya kembangkan, saya akan dapat 3e tambah 3 tolak 1 becomes 2. Okay, becomes 2. Okay, kat sini saya akan dapat 2 bahagi dengan 3 tolak dengan, so we have 3 minus 2e over 3e. So now in order to equalize the denominator again, we are going to multiply for this one with e for both numerator and denominator, right? Then we are going to have 3e squared plus 2e divided by, sorry, so minus with 3 minus 2e divided by 3e. Then so we are going to simplify this. Alright, so simplify 3e to the power of 2 plus 2e minus 3 plus with 2e. Okay, 2e divided by 3e. Then so dekat sini 2e plus 2e become 4e, so saya akan dapat 3e squared plus 4e minus 3 divided by 3e. So this is actually our final answer for unit squared. Okay, so kalau kita tengok dekat sini, so jawapan akhir kita, okay, kita akan dapat balik jawapan yang kita nak kena show that whereby the area of the region is actually 3e squared plus 4e minus 3 over 3e unit squared. So it is proven. So final answer, we can say that it is proven. Okay, so that's all.